So I want to talk to you about how. I really want to start out by talking about some societal megatrends, and then talk about how is robotics really helping shape the world in terms of doing this, and take us through some of the ways that we're doing this here at UCSD, and some of the ways that it's sort of happening in general. So if we look at it, some of the, I'll start out with the key takeaways. The key takeaways is really the world is changing very rapidly in a number of different ways, and I'm thinking about how do we use robotics to do this. And I'm saying the only way we can manage a number of these change issues is by introducing automation to help it. And then at the same time, for this, it's easy for me as a technologist just to say, well, come back here. So we just need a lot of technology. And I'm like, no, we need a lot of people, and we need to sort of think about how do we integrate this into a joint ecosystem of systems that empower people to do things in their everyday life. How do we think about, what are the ethical implications? What are the political implications of doing all of this? One of my backgrounds for sort of talking about this is that I am the principal author of the US roadmap for robotics. So there is a national strategy for how we use robots and how we do this. And I am sort of the principal editor for this. So every 4 years, we do an update on where's robotics going, how is it going to impact people's life, from doing manufacturing to do services to healthcare to all of these things. And then this gets presented to the US Congress, and then I go and beg for money in DC. So that's, if I look at some of the big mega trends that we're seeing right now, is that we're seeing a high degree of personalization. So everybody wants their own product. I don't want the same thing as Peter wants. I want something that's sort of unique to me. We see a significant sort of improvement in longevity. So we get older. The entire world is getting older. I'll talk a little bit about that. We want things that are much more sustainable, but it also implies that we have to sort of think about the world evolves. I don't know why my slides keep going forward without me. And then we do. Maybe I'm talking too slow. But also we have to think about, given that the world is moving sort of exponentially, how do we make sure that we do lifelong education? Because when I got my PhD, the president said, "You're good for life." And was he lying? So we have to sort of think about how do we live in a world where everything sort of changes all the time? And then we have to think about changes to lifestyles. So first, talking about sort of personalization, here is where we are, this car, perfectly nice BMW X5. It's available in 5 million different configurations. We all want different audio systems, all of this, which implies that in the good old days, I could build a manufacturing system that would do this. Today, I had to accommodate the fact that it's built in 5 million different configurations. We all want different things, and that has really challenged us on building this. In the good old days, we could also build my cell phone. We could do it in China because we could send 1 million at a time. Now, because it's highly personalized, you actually want to be able to do manufacturing much closer to where the customer is. Because at the same time, I'm a very impatient customer. I want this, and then I want it to be able to basically go and say, I want to order a new car or a new phone, and by the way, I would like to receive it tomorrow. I don't have patience to wait for it and so say, I just went and looked at a new car and I said, in 6 months you can get it. Yeah, okay, I'm going to go somewhere else. So that's something that's impacting how we think about this. How can we build automation systems that allows us to do this? In an ideal world, I would love to have a UPS truck drive around with a 3D printer in the back of the car. I order something, it gets 3D printed and delivered to me, an hour later. We're not there yet, but that's sort of one of the things we're working on. The other thing we're seeing is that the world is getting older. So the world is getting 8 hours older every day. So if you look at the average population of the world population, despite COVID, it's still 8 hours a day. So the world's population goes up, 4 months every year. And that's sort of interesting. So that implies that the we're doubling the population that are above 65 by 2050. We live longer, so we're seeing sort of a shift on the age pyramid. That implies that a lot of us will go on secondary income. A lot of us will have to sort of figure out what do we do when we get on secondary income. But it also implies that we have less mobility. We need assistance for getting continuous quality of care. More of us would have to go in and get various kinds of surgery and other kinds of things to do this, or get assistance in our home. How can I build robotics technology that will make this possible? So that's one of the questions to work on. We see 82% of the US population already live in urban environments. Globally, it's 66%, so it's only 2/3, but it's increasing very fast. If we wanted to give everybody a house or a roof over their head, we're short 4 billion roofs. Let's set a target and say, what if we could give everybody in the world a roof by 2050? Then, let's make it 30 years into the future and see if that's realistic. That would be realistic if you build a New York City every month, just to give you a sense for the scale of this problem. So we're looking at, construction robotics. What can we do to actually build infrastructure, get it out there so that we can actually do this? But this is a humongous challenge. And we need now, how can we do it sustainably? How can we do it so that even if there's an earthquake in Turkey, we can still actually build these in a sustainable way? This is an area where we use robotics to do this sort of the right way. We think about the environment. I have to say we've made very little progress. But today we built drones to figure out, can we actually do monitoring of this? Can we also use drones to go in and do precision agriculture so that you can go in and basically only apply pesticides where you need to apply them, or remove weed without putting sort of chemicals onto the fruits you want to get afterwards? So very important for us to do this. And this is an area where we're seeing a tremendous amount of growth. And of course, that's very important for a state like California. How can we do this? So this is an area where we're doing it. An area where we're also using, I'll talk about this sort of in the second half, how do we do it? So we need to figure out, how do we do sort of exponential technology? How do we handle exponential technology and do lifelong learning? As an example, how can we do sort of gamification of education so that we can do this much better? So to give you a sense, there are 300 million children in China. This is a lot of people that need to do this. And this is sort of the equivalent of the US population. How do you educate these? How do you do this in a reasonable way? How do we get education in the US that actually has high quality education, which keeps me up at night to do this? So if we're looking at, these are sort of key topics that we need to think about. What can we do flexible manufacturing? What can we do with agile logistics? What can we do with home automation to get all of this? And these are areas where we go in. So for flexible manufacturing, I've already brought out sort of thing. We will see a reshoring of manufacturing in the US. How can we build this so that we can compete with other areas where we do this? It has to be so that we can make it much simpler to do. So you see there's sort of a gamepad or an iPad here that's being used for doing instruction. That's because we want to figure out, today it's very hard to program these systems. Why is it not as simple to do as using an iPad? The average 20-year-old American has spent 12,000 hours playing computer games. This is 10% of their life. If I can build technology that works so that it's similar like game technology, they're instant experts. I can't use it at all. I don't play games. My wife would be able to use it, but me, I would be out of luck. So the question is, how do we build technology that's adapted to people so that they can use this with nothing? And we still have a sizable population today that actually don't graduate high school. How do we make sure we can actually provide technologies that enable them to be part of these kinds of technologies? In terms of agile logistics, we are seeing this where we're getting massive amounts of systems out there that can do sort of automated delivery. So downtown San Diego, I can get a sizable amount of things I want within an hour. So I can order milk and bread and all of these things and actually get it delivered within the hour, because we have these sort of fully automated warehouses that makes this possible. Yet only 15% of all warehouses has been automated. 15%. 85% of them, no conveyors, no automation at all. So there's an opportunity of going in and looking at this, but also thinking about what can we do to do agile logistics, where I can automate things like Long Beach, transportation, all of this, so that it's much more streamlined than it is today. This gets into homeland security and stuff that I don't have time to talk about. We also use this for doing home automation. What can we do to build much more automated homes? I have an 85-year-old mother that would love to be able to get help with cleaning, doing all of this. We've sold sort of 30 million vacuum cleaners, but there's an opportunity of going much further than this, of doing all sorts of home services that would help people keep a clean home, get assistance. I'm still saying, by the time I retire, I'd like to have a robot that would allow me to get help getting out of bed, get help taking a shower, get help preparing a meal, get help preparing or sort of getting dressed. Today, we know we're close, but that's where we're looking at what can we do to build technology that actually makes this possible. Of course, we're also looking at one of the things we do on campus is the future of autonomous driving. What can we do to build much smarter vehicles that would allow us to have much better transportation? So I don't have to sit 40 minutes on I-5 every day to go home from UCSD. And this is not a new dream. It was first proposed in Scientific America, 1918, so more than 100 years ago. And people like Elon Musk will say we made tremendous progress on doing this, so we're getting close to this. Well, let me try and ground you in reality. 1916, the speed of transportation in London was 17 miles an hour. Today it's 12. So it's actually gone backwards. And it's because, you might get the smartest car in the world, but if you're parked on I-5, you might have the smartest car in the world, you're still parked on I-5 because all of the other ones do not have this. So we're lacking a systems thinking of being able to do this in a reasonable way. So we are getting better cars. I'll show you in a minute what we do on campus to do this, but and deep learning and modern computer science are getting us closer, but we're not there yet. So we still have, so even though Elon will say 2 years from now, you can get autonomous driving taxis, I'm skeptical. We try to do this in campus, and I'll show you in a minute so you get a sense. In terms of education, I think there's a huge opportunity for us to figure out how can we leverage technology to make education much more individualized than we've seen before. Today we still have sort of the educational model of the priest on the altar trying to broadcast knowledge to students. I think that was last century. We need to sort of rethink how we do education. And I'll give you a couple of examples. So I'm going to skip this one. Construction, I already mentioned, is a really big project. I won't talk about it. So the question is, he's going to talk about robots. Why are we still here? Why you talked about all of this? So let me give you a few examples of how we use robot technology to do this. I'm going to start out by talking about robots that can empower people in warehouses. This is a technology that partly developed here at UCSD and today getting commercialized through a company called Robust AI, where we're looking at, can I build robots that collaborate with people, where I can have fluency, like if you meet somebody on the sidewalk, how do I build a robot that understands, are you going to go left? Are you going to go right? How can I interact with these people? So this has a tremendous opportunity in going out and actually doing this. Today, there are 500,000 unfilled positions in logistics in the US. At the same time, most people at a place like Amazon only work there for 4 months. And then they said, this is really too boring, or I get repetitive stress injury. So the question is, how can we take this away and replace this with jobs that are much more interesting, but also so that all the dirty, dull, dangerous jobs that we typically talk about actually gets removed and gets automated and used by robots. So you already saw sort of the thing here on the left, which is great. In real life, the 85% of the warehouses I talked about before are cluttered. If you go to Home Depot, there's all sorts of stuff. So we need to be able to build models of these so that we understand where is all the clutter, where are the people, how can we interact with this? And to do this efficiently, we have to sort of address the 80% of warehouses that are completely manual today. How can we do this? So we build a system that's called sort of Grace and Carter, a software system for doing orchestration of thousands of robots, and at the same time build a robot that allows you to interact with people so that it becomes your sort of extended arm. So imagine you have a shopping cart at Home Depot. What if it was intelligent and saying, can you go to aisle 16 and pick up a hammer while I go and pick up the extension cord in the other one? How would we be able to do this? That's sort of what we're trying to do here. So, we want to build this in such a way that there's no software. We can't have time where you run around and do programming of this. We have it still, so it's highly optimized, and it has to have situation awareness, so it doesn't run into people. And how can you do this in such a way that you get to this? So we built a system for this where we have sort of robust autonomy. It does collaboration with people. It can easily interact with you. So it's a cart that drives on its own. As soon as you touches it, it will actually allow you to take over and do sort of smart intelligence. So we built this. I'm going to skip this and get you to a video where you can sort of see how this works.
At Robust AI, we believe that adding automation to increase productivity isn't about replacing people with robots. It's about making the great people you have insanely productive and engaged, accomplishing more by using better tools designed for them.
So, we've invented something we call collaborative productivity. It's going to improve operational efficiency and employee engagement. Now, in the past, I've defined and built completely new classes of robots, from the Roomba to the Packbot to Sawyer. And now we're building a new iconic class, Carter. Carter's a new type of robot. It's built not just to work near people, but with people. It can complete its work autonomously, but at the same time it's responsive to people and its surroundings. And then with a simple touch of its handle, it changes modes, becomes the ultimate power tool for any user. Carter's handle enables people to maneuver it intuitively, allowing them to move heavy payloads with ease. And they don't have to be trained. They just have to see someone else use it, but they know how to use it. Many autonomous mobile robots, or AMRs as they're called, make people feel unsafe and unseen, making operations less efficient. What we do is put people first, and we've built robots to empower them. A truly collaborative mobile robot that moves in coordination with people like a responsive dance partner. Carter works with you, moves with you, and flows with you. In the future, that's how mobile robots should be. They should know about us as people, and you should be able to go and grab them and change what they're doing. Together, we can define an entirely new category of robots, paving a way to flexible, high productivity automation that puts people first.
So that's sort of an important part of how can you do this in regular workplaces, of building robots that really sort of collaborate with people. How do we understand people well enough we can do it? How can we understand what is their intent? What's the best way of collaborating with them? And then how can we do it? We did a similar experiment on campus for, could we automate the vehicles driving around on campus for doing mail delivery? So we're interested in, can I take this, and we have, as you know as well as I, we have about 70,000 people on campus every day, half of them students, half of them faculty and staff. Can I drive in this environment where you have sort of a lot of stochastic changes, and how well would we be able to do this? So there's lots of autonomous driving, people trying to do autonomous driving on the highway. I want to be able to do this in a place where we have 30,000 students walking on campus and they think of themselves as owning campus. So you better find out how to drive around on campus without running into people. How do we do sort of the last mile transportation? We just got the trolley stations, and on the trolley stations, they are actually half a mile away from the Jacobs Hospital. How can I go the last mile without having to do this? Can I build a system for that? So that was an experiment we set out for ourselves to do on the campus. What would it take to have these drive around, cover both again? We can't go to Scripps because we can't get on North Torrey Pines and actually drive around, but we can still sort of build vehicles. So we built a couple of golf carts, retrofitted them so that they can drive with nobody in it. Build a software system. I'm not going to spend a lot of time on it. It does navigation. It understands what's going on around you and gets to sort of a place where we can actually do automatic tracking. So let me show you a brief video of what it looks like for our 6 months sort of mail delivery experiment that we did on campus.
Hi, I'm Henrik Christensen. I'm the director of the Contextual Robotics Institute here at UCSD, where we do autonomy, smart robots for all sorts of applications. Right here, you're seeing our automated mail delivery system on campus. So the experiment we're trying to do here is to understand how can we use these vehicles for doing micro, sort of the last mile logistics. And it's interesting to try and test these in a campus environment where we have regular traffic, we have pedestrians, we have scooters. So this opens up a number of new challenges for autonomous vehicles. We bought a vehicle, it's retrofitted so that we can do autonomous driving. It has cameras, it has a LiDAR, and it has various other sensors on there. And we've then programmed it so that it would automatically know where it is. It will detect other things around it, like other vehicles and pedestrians. And then we've sort of developed the logic to enable it to participate in traffic, so it can stay on the road, it will stay behind another vehicle. When we get up to an intersection, it will read what other vehicles are at this intersection, whose turn is it, and then it will use this to drive through it. So it will drive just like a regular driver through traffic, except it's all done by a computer.
So of course you should think by now, wait a minute, there's still two guys in the car. Yes, I forgot to take into account that mail delivery on the UCSD campus can only be done by unionized people. So there's a guy in there that has sort of a logo on it because we couldn't do this. But it was a great experiment with campus to figure out what would it take to actually be able to do this with automated deliveries. We just started a second experiment to figure out. We did it to 6th College, and we did it to I'm trying to remember who else did we do it to. It'll come to me in a minute. So Warren. So we did Warren and 6th College and did all the mail deliveries for 6 months. We wanted to know, when does this technology fail? How can we build in things where we can predict pedestrians? Can we signal to people, I'm going to turn left, I'm going to turn right, I think it's my turn now, which actually was very successful. And the students love it because they all go off and get jobs that are much better paid than me. So our lessons here is that we did sort of 6 daily mail runs for 6 months. We did mapping of the entire campus, did a lot of sort of fundamental technologies that are being used for this. And now the next thing is we want to be able to start transporting people around campus without drivers actually in the golf carts to do this. Nice. The other area that I'll do very briefly is sort of we're looking at what can we do to do lifelong learning? What can we do to build robots that would assist on doing this? One of these technologies was initially developed by this company, Embodied, one of my former PhD students, for children with autism. Can we help? They are worried about doing sort of social interaction with other people, but they're very happy doing social interaction with a robot. This has now been sold in more than 10,000 units, where we build a model of what does it take to become a friend with a person? How do we build these language systems? I'm sure you've seen in the press, we now have these large language models that allows you to have a very rich interaction with a person, personalize it, and make it highly accessible to these. I was part of another project in China where we looked at this robot for, in China, they would typically have people or children that have a mentor that would come up. You go to school, go home from school, you have a mentor, which is not always very popular. So the question is, can I build a robot that would become your mentor, that would individualize to you? And we would play it. And then we build sort of a game model for how do you interact with children. So let's say that you're somebody that's not very happy about doing math, but you're very happy about dancing. Then we would gamify it, saying, if you solve these 3 math problems, we will do a dance. So how do you build it so that you can incentivize the kids to continue to do education? This has been incredibly popular, and we've sort of tested a model for how can you engage with this and make it much more sort of targeted to how children would like to actually have an educational model. We also use this on campus to teach robots how to do, or teach children or students how to do robotics, which has been very popular. So right now I have twice as many students signed up for my robotics classes as we can actually do. But still, there's sort of a lot of interesting opportunities here. So for me, I know I'm supposed to wrap up after 30 minutes, so I'll try and wrap it up sort of quickly. Our lessons here are more we can go out and build sort of effective tools for building sort of toys for children that can be used in an educational environment. So our world is changing very rapidly. We see that there's a need to be much more personalized, to build technologies that empower us rather than us being empowered, being sort of lost in technology. So we're trying to do this and build quality of life technology. So the center I run at UCSD, we have medical robotics. So we do surgical robotics for this. We do assistive robots for people in their daily homes. We build component technologies like hands. How can I do to sort of build technologies that would be the equivalent of the sensory feedback we have in hands? And how can we then deploy this in everyday settings to evaluate it? So we're not so much about building what I would call lights out factories of replacing people. We're really about how do we empower people to do things that are either dirty, dull, and dangerous, or things where it would be hard for us to do it on our own. And with that, I'll stop and be happy to take questions.
Thanks very much, Henrik. That was really fantastically interesting. I really appreciate hearing all that. And we are open for questions. Remember how to try to raise your hand and or type things in the chat, and I will try to keep track. And while we're doing that, I'd like to ask a kind of a question with two sides in it, which is what do you find is the major constraint on the research and product development that you do, and what are the major enablers? What prevents you from doing more, and what allows you to do more?
So now that's a good question, Peter. So I think one of our major constraints is we're still very far away from understanding people. And what I mean by that is really all aspects of building cognitive models of humans. What's the right way of doing this? How do I customize robots so that it fits your life pattern and not other people's patterns? But also down to, we have amazing sort of mechanoreceptive systems. We have all of this flexibility. We are still in the stone age of building haptic sensors and these things. So it's easy to get inspired by what people do and then say, oh, we should be able to do this. And then once you look at this sort of integrative, I need to be able to build better sensors, better materials, better computing to be able to do this. So we're very far away from being able to build something that is even remotely as good as people. So that's one of our limitations. One of our powers, I would say, is that computing power has moved tremendously the last few years. Now I have more computing power in my cell phone than I had in my computer when I was a graduate student. And the fact that this really sort of enables me to do things that we had not imagined we would be able to do before. At the same time, we're getting much better cameras. So better cameras, better computing, very inexpensive. So I would say we're not technology limited anymore. We're limited by science, understanding the foundations that allows us to then from science, take it into engineering so that we can build artifacts and actually deploy it in the world. The science is still holding us back.
Mm-hmm. So it sounds like the world that you deal in is when many things are happening in many different fields. And your hope is that there'll be a breakthrough here and a breakthrough there, then you're going to assemble the pieces together to go forward. So, I mean, but I find it interesting about that. It's not as if, doesn't sound as if that you can design, well, if I want a breakthrough in this particular thing or hospital technology, it's not like you can design a project that's going to do that, because you need the world to produce 10 different innovations.
I'm always saying, you all work for me. No matter what study you do, I benefit.
Right.
I'm the benefactor of progress in material science.
Yeah.
And if you look at it, I have in the Contextual Robotics Institute, I have people from CoxI, I have people from material, I have people from sensors, I have people from computing, I have people from data science. I need all of these to be able to make next generation systems.
Yes. But when you think of where the funding comes from, does it come from the development of each of these other systems by that particular ecosystem, that world, that product development world, or are there funding sources specifically around the projects that you're doing? Again, let's say take medical as an example.
Right.
Does one, if you want to develop a specific thing, do you go to the sources of medical technology development and say, I want to build this and get money for that? or do you identify a bottleneck and try to break the bottleneck? Where does the money come from?
So, not a good question. And as an academic, we're always struggling with how do we get funding.
Yeah.
I've sort of taken a unusual approach in the sense that when I came to the US 16 years ago, I was in Sweden before, and I was very frustrated. I felt we didn't have a good funding source. So you can get frustrated or you can do something about it. So I went to my colleagues and I said, we need to have a strategy for how do we get more money. And everybody said, oh, we've done that. It's impossible. We don't know how to do this. I said, let's make a deal. We're going to write a strategic document that I'm going to go and sell in DC. And if we get money, you're all going to get a bigger piece of the pie. And if we don't get money, you can all point fingers at me and say, oh, Henrik is an idiot. So there was no downside for them. So they helped me write a strategic roadmap for how can we do robotics in the US. I managed to collect or set up a congressional caucus for robotics with 40 congressmen in it. And the congressmen are actually fairly useless. But the staffers are really good because they are actually the collective memory of DC. So I worked with the staffers on briefing them on how a robot's used in Mexico, in the Mexican Gulf for cleanup, how we're using them on Mars for doing science exploration. And then eventually when we had a roadmap, I went and I presented it to Congress, and the White House called me and said, they have no money or in Congress, you need to come talk to us. I said, well, that's why we have taxes. So I went to the White House, talked to Tom Khalil in the White House, and he got very excited about this and set up an entirely new funding program that has been funding at $700 million. So, rather than getting frustrated that I don't have enough money, we set up a new funding program for this. At the same time, it's very important for us to also work on how do we build a pipeline to the companies. So we work with Amazon, we work with Nissan, we work with Qualcomm to make sure that our technology gets out of the lab and into the real world. So I would say we have an applied money stream from the companies, and we have a program in the National Science Foundation and NIH and USDA for the fundamental science. But it took a lot of effort, but it's more, I think, more and more, as an academic, you need to go and build your own money streams rather than waiting for somebody to show up and give it to you.
Mm-hmm. And so do you think the companies are feeling threatened? I mean, you're developing products which are going to threaten what they already have, or do they see opportunity for the next big thing? They want to be on the curve before, they want to do something before somebody else does it first.
Well, so no, it's a good. So first of all, I think it's very important. We should not become an engineering shop for doing this. We have to work with doing the fundamental research, but then we need to have a path. And UCSD, Paul Robin, and those people have become better and better at how do we build a pipeline to get it into the real world so that we can go back. And I would say we're seeing manufacturing coming back to the US. We're seeing new ways of building sort of medical technology. And then we work with those companies to figure out how do we transition it to them so that we get the licensing at UCSD, which we roll into new R&D efforts to do this. And the most important resource I generate is human capital. I educate, or we educate, we have about, what do we have, 20 faculty and 200 graduate students, and God knows how many master students and undergraduates. The most important we generate are these people that go into the real world and change it, whereas I continue with the faculty to stay here. So I think we have a very healthy ecosystem of doing fundamental research, teaching some people how do you build interesting products, and then get industry to take it over and take it the last of the way.
Okay, Alan, you have a question. Go for it. Click on unmute yourself.
Will do. I wondered what ideas you have about how robotics can help us address our problems with non-polluting industry and climate change.
Oh, no, good question. Very good. So several strands here. So I think one of them is that if you look at, for instance, we did a large study with some of the automotive companies, and it turns out that, which should not surprise you, that computers are actually better drivers than people are. So with autonomous driving cars, the energy usage is about 20% less than it is for people. We tend to maybe accelerate too much or do this. So in comparison, autonomous driving cars are actually 20% more energy efficient, which will help reduce this. But then I think the other thing we're seeing is that we can find ways of doing much better cleanup. So we worked with Scripps Institute of Oceanography for plastic cleanup and a number of these things. I think you would see that we can clean solar panels much more efficiently to guarantee that solar panels continue to have high efficiency throughout their lifetime. So I think what we are trying to do is look at this sort of from a systems perspective. If you look at the entire systems, where are the weak points? How do we clean the solar cells? How do we build the right kind of transportation to do this? How can we use robots to go and clean up the oceans, which are very hard for people to do? So we want to, again, use this to sort of complement people. Robotics is not going to be the final solution, but I think it's going to be an important tool for us to become better at doing climate things, but also things like how can we do better production of food? How can we do better mining? How can we do? So there's lots of these places where I think it's not going to change it 100%, but if we can keep sort of chopping off 5% in the various sectors, we will still be very efficient.
Thank you.
Sure.
Yeah. Other questions, comments, observations? Because I've just in political and social reactions, what do you see as the constraints out there in society? What are the obstacles aside from money? What are the social and political obstacles to the kind of work that you're doing out there?
Multiple. So the first one is sort of the stigma. Most people, when you say robotics, they're like, oh, they're going to kill my job. They're going to go and take my job, right. Which is actually not true. So I have sort of a statistical report that sort of shows that you invest in automation when you also invest in people. It's not. It's very, very. The correlation is almost one for that, and so, but that's not what people have. And Hollywood is probably my biggest obstacle. Because they project sort of robots as being dangerous, they're going to come and kill us and all of this, and I'm like, how can I get a Hollywood producer to do a movie about all the benefits rather than all the problems? So there's a lot of stigma around this that I think is a problem. And then I still, I see from a technology point of view, the robots are still too expensive. We need to get to a lot more of these robots that are sort of in the $1,000 range, where we can get them into every home and you can see them. So I'm fighting my colleagues to sort of say, stop building Rolls Royces. We all need Volkswagens and not Rolls Royces. And we're slowly getting there. But again, getting this then to build systems that can be used by people that have no training. This has to be, and here the societal challenge is that the spectrum is very different. As I said, the average 20-year-old American has spent 12,000 hours playing computer games. They want a gaming interface. I'm too old to have used games. When they give me a gamepad, I look at it and say, how do I use this? This doesn't make sense to me. So how do we build systems that have universal interfaces in some sense for this? From a societal point of view, one of the other stigmas we have is privacy. People are worried about, is this going to monitor me? Is this going to intrude on my life? Is it going to take pictures? Is it going to do? So we're doing a lot of work to make sure that we can build systems where we can prove to people that there is no privacy issue. Because this is, people are getting more and more worried about this. The millennials don't care. They're like, it's on Facebook. Who cares? I care. I don't want my pictures to be on this. So I think. And I think it'll come back. Suddenly people will realize maybe there's more out there than I really wanted to have. So see, I see there's a question. And so do I work with people in ethics and practical ethical? So no, exactly. So you're talking about so we work with, I don't really work with people here at UCSD, but we work with, for instance, Brian Kalo at the University of Washington, who is in the legal school there and is very much thinking about sort of the ethical implications. And it's a very broad spectrum of ethical implications. So you have to think about this from the point of view of what can we do to, what can we do about the privacy of making sure that you're driving around? If you have a Roomba at home, it has a camera, it is taking pictures. And the question is, how can we make sure they're not getting communicated out? We've seen this with an Alexa, where there's all of these sort of, is it listening to what's going on in my home? Can I trust this? It's not, but it is sort of a concern that people have. At the same time, there's a motion in California right now. Can we make sure we're not weaponizing robots? Can we make sure that we're not putting guns and whatnot on robots, and that could become a major threat for this? But also people are worried about larger scale privacy issues. So you might not be aware of this in Chula Vista. If you call 911, they're going to send a drone. They're literally sending a drone to where the call originated, doing downward imagery, and using this to decide how many police cruisers should we send, how many ambulances, how many fire trucks. So, and then based on this, you're getting an appropriate response. So, but then people have actually complained about this and said, it's great that you can use this, but how do I know you're not taking pictures if I'm skinny dipping in my backyard? I don't want you to be able to take pictures of this, what's going on. So there's a lot of these that we have to take into account to make sure that we do it the right way. So it's not only important to do the economical consequence, but the ethical of what is appropriate, what can we store of information, what can we not store of information, and how do we do it right? So it's a very important part of what we do. I haven't found the right people to work with at UCSD, but we work with people internationally on doing this.
Yeah, I would imagine there's a social side. One can say that the number of jobs won't go down necessarily with robotics, but the social structure of the jobs changes. You might say that Amazon, for example, might employ as many people as the old retail system does. But the difference is that they all work for Amazon, one enormous employer, rather than for a lot of smaller mom and pop or different kind of stores. That's a very different social and economic structure.
Oh, yeah.
And so it's kind of not enough to say, well, we're not destroying the number of jobs. Yes, but you're changing society very drastically.
Oh, yeah. No, absolutely. But also there you're seeing people actually very unhappy working at Amazon and
yes.
these on UPS, FedEx.
Right.
People only stick around for about 3 months, and then they said, this is not what I want to do with my life.
Right.
So it's important that we build quality of life into these jobs rather than just saying they're just, human machines.
Right. Absolutely. There's a comment in the command that there is a group at UCSD that focuses on digital health ethical research, and it's mentioned. The URL is in there for you if you're interested in that.
I'll look at it. I'll definitely look at it. So as an example, I have one of my PhD students who his first degree was MD from Columbia, and now his second degree is a PhD in computer science, and he works on how do we do digital health. But so as an example, he monitors surgeons to decide when very sort of talk about ethics and being potentially unpopular, trying to tell surgeons how good they are at doing surgery.
Well, that's hard. Yeah, well,
I'm telling you, there's a lot of egos involved in that. But the
Yeah.
other thing is we're also trying to do is with Linda Hill, who does, we're studying when do we consider people to be competent drivers, but also when do we consider people to potentially not being able to drive anymore. So doing studies where we're using EEG, ECG, and all of these biomarkers to measure what kind of cognitive capacity do you have as a driver, and when might it not be appropriate to drive anymore. So this is an example of some of the stuff that we do that's sort of related to when should you have an autonomous driving, and when should you be able to drive yourself?
Yeah. How far away do you think we are from self-driving cars? From
I
safe,
think we're
as opposed to the Elon Musk idea, the safer
Right.
one, the really safe ones. I mean,
right. No, so I think we will. I'll give you two different answers. So driving on the highway, we're getting very close, where you have sort of an autopilot and you can drive from Del Mar to LA. Once you get to LA, you have to take over control again.
yeah.
On the highway, I actually think we're less than 5 years out.
Wow.
For driving on the UCSD campus with 35,000 students walking all over the place, not paying attention to traffic, it's not going to be within the next 10 years. It's probably not even going to be within the next 15 years, because this is really hard.
Yeah. Yeah. I see. So freeway driving, maybe 5 years, but
Yeah.
the details of inner city driving, who knows? Yeah.
It's but even there, it's also for some of this, like, so we've studied with Linda. So if you take your cell phone, you look at it, oh, it was an important email, or my wife sent me an SMS that could you pick up milk on your way home?
Yeah.
It takes you about 30 seconds to gain full situation awareness of what goes on around your car.
Yeah.
Building a system for a car that can actually predict 30 seconds into the future of what's going to go on at the road is really hard.
Wow.
So, and that's what it would take to take over. Can you predict what your traffic at your intersection look like 30 seconds from now? Even we, in most cases, can't do that. And that's what we are asking the car to do. So it'll take a while.
Interesting. And what do you see? What's the role of a university in this entire system that you're describing? You emphasized earlier in our conversation the training of students, which of course is a huge role for universities, is educating people for their lives, their personal lives in the workforce. Would you say a little bit more about what should the university do? I mean, that matters. How many people should the university be hiring for that process? How much money should it be putting into this? I don't really know.
I'll give you two different answers. I'll give you a research answer and a educator answer.
Yeah.
So I think from the research point of view, I think we have to not only look at, can I build autonomous driving cars? We also have to look at what should the future of urban planning look like.
Yes.
How do I plan the right now, I live in Bankers Hill, and whoever designed the urban planning in Bankers Hill should go and get a new degree, because this sucks to a degree that I could not imagine. But we should think holistically, and as a university, we have the advantage, we have all of these competences we can bring together. So don't try to just optimize cars. We should think about, how do we build much better societies in terms of environment, in terms of all of this. And I think we as professionals tend to go deep rather than think about, how can I help my neighbor? So I would love to see more collaborations where we do these cross-disciplinary collaborations for this. In terms of education, I think we have to rethink the university. So I'm of the belief that we should build an educational system where you sign up for lifelong education. So I used to be at Georgia Tech before I was at UCSD. And there we've done online education, thinking about this. I think you should sign up for a subscription to have 4 hours of education per week for the rest of your life.
Yeah.
So there's no way I can teach you everything that you need to know now for the rest of your life. But what if I could come back and it should then become an integral part of your daily practice, that 4 hours a week I get updated and educated on the latest, whether it's literature or social sciences or math or whatever it is. But I think we should have a library model to the university. We're teaching people in their job so that they get the next level of skills for whatever they need right now. So I think we will see a dramatic shift away from in-person education to online education that will completely revolutionize the system.
Yes, I think so. I tell you one thing that does terrify me, and I wonder what your thoughts are, is all the stuff I've been reading since I'm sort of in the word side of our university, is the innovations that are now making it possible for people to have their papers written. by these programs, and that scares the hell out of me. Is the idea of, I have a bunch of term papers that are due tomorrow, actually, or proposals for term papers, and I'm getting more and more scared about how am I going to tell the difference between this is really them and or something that they hired. And I actually have a technique. I'm going to examine their emails. I want a program that can compare their emails to me with what they've turned in as a text. Because I've noticed that this is really, ethically unfair. There are some students whose English is, shall we say, not as terrific as it might be. And so I'm going to compare what I think is their quality of English in their emails with what they're turning in. And
Right.
if their papers they turn in are too good, well,
Yeah.
but I'm very scared of this. I see several colleagues on the screen and work in the same area, but most of us are retired. I only teach in one course a year, but those programs, that make it easy to write papers are really quite frightening for people in
Right.
various branches of the
So-
university.
And I agree, and I think we're probably in for what I would call an adversarial sort of, the question is how we're going to build better and better checks. So to give you an example, I'm on the science editorial board. We will not accept any papers where any part of ChatGPT has been used to produce the paper. So,
Right.
so we've sort of said this is not, so how we check that? A good question. But I think we're sort of in for a war on this. I'm happy
Right.
that people have gotten better grammar checkers, better spell checkers,
Right.
all of this.
Yeah,
That's
I
very
use that,
valuable.
yeah,
But
right.
but where is
Right.
this limit? And that is really scary that we've gotten to. They've become really good. But it's also, Joe, I recently did one. I forgot. I went to Google 2 weeks ago to talk to the leadership. And the night before, I did sort of 10 tests of these online agents to see how good they are. And all 10 questions I asked the system had fundamental sort of philosophical errors in the answers. Where I looked at them and said,
Yes.
student
Yeah.
handed this in, I would say you failed. So
That's
this-
encouraging. That's another read closely is the answer.
exactly. No, so we have to be very good at reading this to sort of make sure. I look at it. So there's a logical blunder in this argument, and I tell my students that you can use it in answering your questions.
Yes.
If I suspect there's a problem in here, I'm going to have an oral exam with you, and you're responsible for all parts of your answer. And if you can't do that, you failed.
Yeah, you increase the penalty, right? Exactly.
You have to increase. And so they said, no.
Yeah.
Here you said this is 34. Explain to me why. And like, oh, I used. Okay, you're out.
I suggest ask to see their email. Look at their emails. I get emails as my cat is sick. I have to take care of it. And well, you compare the wording of that email, with what they're saying about the origins of World War II, and how good are they doing? And they're not good.
That's hard.
Yeah. No, but I mean, in some ways, I find it very thrilling. I use various translation devices. Google Translator is quite remarkable because I use language sources that are beyond my skills, too many languages, but they're amazing. It's amazingly powerful. Of course, it makes mistakes, but that if you're not literally using it for perfection, if you just want a sense of what did that article say, boy, they can give you a incredible amount of information, and that's very impressive. So there are some wonderful things. I'm not against it. Just that there are costs.
Yeah. But I have the same, so I'm Danish by birth, and my wife is American, and she communicates with my mother using one of these automatic translation mechanisms, and I'm amazed about. It's good enough that they can actually have a dialogue.
They can talk to each other. Yes.
Yeah. No. I'm like.
Oh, they do it orally. It's not they do it orally. Oh wow, that's amazing. Yeah.
Yeah.
Yeah. Very impressive.
No. It's amazing.
It's impressive. Okay, folks. Do I see any more questions on the? I don't see any more hands up, and I don't think I've missed anything in the chat. But this is an amazing world. I sort of share your. I kind of share your excitement with it. I sort of have the I'm awed by it, and I find a lot of exciting things happening. But I feel that, you know, with so many of the exciting things that happen that produce tremendous social change, social and political change, and we don't really know how to do them. And I think it's interesting that in your case that some of the things that you're doing, that's part of the issue. I mean, that is certainly part of the things that you're studying when you're designing new cities or new products, things like that. You have to know how the human beings are using it and how they interact with. The only thing I have in my house is I bought myself one of those, you know, circular vacuum cleaners. I don't know what they're called, but and it's cool. You know, it's not the same thing as doing a vacuum cleaner yourself, but if you need just to pick up the dust and little pieces of paper, it does a very remarkable job. And
we have two at home. So I was actually on the team that developed one of those vacuum cleaners. And for us, it doesn't do the cleaning, but it makes the difference that we have a cat. And we now can have a lot of people that are sort of allergic to cats
it picks
come
up the
over because the amount of dander in the air is low enough that it doesn't actually impact them, which I never even thought about that as being an option. So I think it's very nice, but I think, Peter, as you said, the most important part to me is that we need to think about this holistically. How does this think? It's not enough that we do sort of a thin slice of science. We need to think about what are the global impacts and what are the sort of system level impacts of this. And I feel very privileged. I work in a place where there's a lot of people that are much smarter than me, but I can benefit from cherry picking of it and actually using it to build stuff that changes people's lives.
Oh, that's very exciting. No, I think a lot of exciting things on there. And as I listen to you talk, my mind keeps on trying, wow, what about this person? That, you know, that first, I know somebody in sociology he could talk to, or somebody in communications. So they're so interesting. There are people who are studying, you know, the gig economy, I know people who are studying how people work in these work situations on the sociology and psychology of it. So a lot of interesting connections to be made there. Okay.
Right.
Well, thank you very much, Henrik. I really very much appreciate your doing this for all of us, and thank you.
Thank you for having me. This was great. And if you have suggestions for people I should talk to, I'll
email you. I'll email you their names. I will do that.
Thanks.
Okay. Thank you, everybody.
Hey, have a good day. Bye.
Bye.